In this video, I will talk about complexity of algorithms. There are two kinds of complexities involved in algorithms. So we talk about machine learning algorithm, then there are some computer vision algorithm, but every field has many algorithms. But we need to look at certain criterias, which algorithm is better than the other one. So there are two ways that we can generally compare algorithms. One is the time complexity, and the another criteria to have a good look at algorithm is the space complexity. There are other things as well, efficiency and accuracy and so on, robustness, etc., etc. But generally, here we discuss the complexity in two ways, which is time complexity and space complexity. Let me just start with some particular examples over here. Suppose that there is a library, and in that library, there are 10 books. There are some books over here, book one, book two, there are book one, book two, book three, book four, and book five, so on. So there are some books in the library, in this library. If you want to look at some particular book, for example, if you want to look at the book number five, then what you have to do, you will look at the book number one, then you will see book number two. If you want to see book five, so you need to go book three, book four, and book five. So it means that you have to make 5 attempts. If there are 5 books, then you have to make 5 attempts to reach at your desired book. Now imagine that if there are not 5 books, but there are 10 books. Then we have book number 6, book number 7, book number 8, book number 9, and book number 10. And if you want to find the book which is book number 10, so it means that you have to make 10 attempts to get the book number, maximum 10 attempts. But if you want to look at, if you want to see some book number one, then you need only one attempt. Okay, it just, you don't need many attempts to get the first book. Only one attempt is enough. If you need eight, and the book which is at place 8, then you need 8 attempts, so on and so forth. So maximum attempts you needed is the uh, 10 attempts. And similarly, if you just extend that, then you have, if you have 10,000 books, then uh, it means that you need 10,000 attempts. So it grows linearly. So it means that if your algorithm is working similar to that, searching a book like this, then it is a linear, it is has a linear complexity. Okay, it is slow. In other words, it is a slow algorithm, and such algorithm is known as linear search, and such algorithm is slow. Now what you do, you don't want to have 100 attempts or 10,000 attempts, or your algorithm, actually you cannot do it physically to look at 100 or 1,000 books, but you make an algorithm, a smarter algorithm that is faster than this linear search. So what you do, you divide books into two sections first. Divide books into two sections. Two sections, for example, you make book number 1 to book 1 to 5 book 1 to 5 as one section, and book 6 to book number 10, you first made two sections over here. So you actually divided your books into half. So every time you make these books, or one section of the book where you think that there is a book, you can divide into, for example, book 6, book 7, book 8, book 9, and 10. You also divide this into two halves as well. So it means that every time you start with some interval and you make your interval half, where you think that there can be a book on the other side as well. So it means that when we had linear search, in linear search, in linear search, we had 10,000 attempts. If there are, this is the worst case, 10,000 attempts for 10,000 books. But if you have this search algorithm that I already discussed, this is called binary search. In binary search, you needed only 14 attempts. 14 attempts. Now the question is how this has been calculated. For binary search, the algorithm has a power log 2 10,000, and it is approximately 14 tries. So for linear search, we had 10,000 attempts, and for binary search, we had only 14 attempts. So here you have seen that the algorithm, the growth of algorithm is very important. Which algorithm is faster? It depends on the function that you create through the theory. Now, this was the general introduction of the time complexity or space complexity. If you want to relate this into time complexity, you see that if you have 10,000 attempts, you need more time. More time. So it means that we are talking about time complexity. Time complexity means how much time your algorithm takes to get you the answer. And similarly, when we talk about the binary search, the time complexity is very small. So it means that this algorithm is very good, which gives you answer after only 14 attempts. Try to understand the difference between time complexity and space complexity is important. Suppose we have in the class, now I want to distinguish between time complexity and space complexity. Suppose we have in the class three students. Then if you want to call out their name in the attendance, then you have to call them one by one. So you need to check the register where you want to have, for example, the student A is in the class, student B is in the class, correct? Student C is in the class, so on. So you have to check three times. If there are more than three students, maybe there are, for example, 100 students, suppose. If there are 100 students and you have to mark them present in the present or absent, whatever the situation is, then you need to call their name 100 times, so on. So this is actually the thing that you are talking about is also time complexity. Time complexity. For calling 100 students, you need more time, but calling three students requires less time. So your algorithm, if you translate this into the algorithm, then you have more time for more students. So has a time complexity involved. And what time complexity of this algorithm will be? It will be order of n, big O notation. Since number of students increases, time increases linearly. It is similar to the graph that you discuss in calculus. When we increase x, the function also increases accordingly. This is called linear function. Okay. Now, what about the space complexity? Now, this was example of time complexity, and the previous one was also time complexity. Now we want to see what is space complexity. Space complexity. As the name suggests, it tells us how much space is required to run an algorithm. Okay, suppose that if you have 30 students, if you have 30 students in the class and you write their name on the sticky notes for the memory location. For example, you say student A has this name, this requires sticky notes, student B, then you have C, so on. So it means that if there are 10 students, then it means that you need some space to save them on your desk or wherever you want to put them. So if you convert that, for it means for 300 students, maybe I just need to extend that idea. And if you have 300 students and you write the name on sticky notes for 300 students, it means that you need to have many many more space than the previous one. So it means that you need more space. This is called a space complexity. The space complexity is also order of n, since as you increase the number of students, you need more space, linear space. So this has also the space complexity order of n. So you need more memory, more disk, more nodes, etc. So finally, let me just talk about some algorithms. There are different algorithms. For example, we have, after time and space complexity, we have some algorithm which are order of 1, then we have order of n, then some algorithms are order of n square, then we have order of log of n. These algorithms has order of 1 has a constant complexity. It means that, for example, if we have a 1, 2, 3, 4 that is written in MATLAB, then if you want to call the third element, you only need a3, that the answer will be equal to 3. So it means that even if you have 500 elements, in order to call the element at the place of 400, you only need, for example, a 400. So that is very easy. So such algorithm is order of 1. It has a constant complexity. And order of n has a linear efficiency. Then we have quadratic, then we have quadratic, then we have logarithmic. Logarithmic is a bit faster algorithm, and quadratic is slow, since as you increase the number of inputs, it will grow uh, very fast. It's a kind of parabolic kind of algorithm. So n is the input. So what algorithm we have over here? The first one is linear search that we already discussed, linear search. Then we have, for example, in quadratic case, we have bubble sort. We have bubble sort, and then we have nested loops. We have nested loops, so on. And then for log of n, this is very efficient algorithm, that is binary search. These are the algorithm. uh, there are many other ways. There are other algorithms as well, but these are some of the important algorithm for space and time complexity. Thank you for watching.